use the matrices to find or to form the image, to find the distance of the image, the height of the image and whatever. All this we will discuss in next lecture, last lecture. But today's lecture, theory wise, it is the last topic. And it is about the cardinal points. So we know that here we are not going to consider only one thin lens. We have to consider series of lenses. See, if we have any complex optical system, telescope, camera, whatever, so that system consists of many lenses. And according to Gauss, in 1841, he predicted that this lens system is considered as a single unit. And then the lens formula, that our lens formula is 1 upon d2 minus 1 upon d1 is equal to 1 upon f. That lens formula can be used if we measure the distances from two hypothetical parallel planes. Suppose આપણે lens formula use કરવી હોય 1 upon d2 minus 1 upon d1 equal to 1 upon f. આટલી મોટી સિસ્ટમ માટે જેમાં 10 થી 12 લેન્સ હોય તો કયા લેન્સથી આપણે બધી ડિસ્ટન્સીસ મેઝર કરીશું? એ બધું બહુ જ કોમ્પ્લિકેટેડ હોય. એના માટે આ જે કાર્ડિનલ પોઈન્ટ્સ છે એની ફોર્મેશન કરવામાં આવ્યું અને these planes are known as the cardinal planes કે જ્યાંથી આપણે બધા ડિસ્ટન્સીસ માપવાના છે અને એને થિન લેન્સ ફોર્મ્યુલા એ જ પ્લેનથી માપી અને આપણે એપ્લાય કરવાની છે. તો આ છે કાર્ડિનલ પ્લેન્સ એન્ડ ધીસ plane intersect the axis of symmetry. They at some point, and that point are known as cardinal points, are also known as the Gauss point. So there are 6 such points. They are very important. In which the first point are 2 focal point. You already know focal point. Focal length તમે માપો છો અને focal point પણ તમને ખબર છે. Second is very important. And that is a complex system માટે આ second point is very important. They are known as 2 principal points or unit points. And the third one is called 2 nodal points. So for any complex system, focal point karta પણ these points they are very important and they are 2 principal points. તો પહેલા આપણે focal point ને તમે ભણી ગયા છો પણ આપણે એને ખાલી જોઈ લઈએ કે what are focal points. Suppose this is our optical system. This is the axis of symmetry. And the ray on the left hand side space is always considered as object space, while right hand side space is always considered as image space. So from some center of the system, left side and from the right hand side. We can say that here there is one point on the axis of symmetry. This point is such that the ray emerges from this point like this. Then after passing through the optical system, they becomes parallel ray. So such a point is called the focal point and the plane is called the focal plane. This you already know. Similarly, there is another focal point in image space. How we will create it? Anybody? In the image plane, image space. Do you know how to create the focal point? The rays, they are coming from infinite object. They are parallel rays and after passing through the optical system, they converge to one point and that point is called the focal point of image space and we call it is F2. This is represented as F1, this is considered as F2. And now we are going to concentrate upon our important plane and that is called unit planes. જે આપણે પ્રિન્સિપલ પોઈન્ટ અથવા તો યુનિટ પોઈન્ટ કન્સિડર કરવાના છે એને આપણે યુનિટ પ્લેનથી ડિફાઇન કરીશું. સપોઝ we have optical system. બરાબર સમજો. we have to consider optical system, and this is the axis passing through the middle of the optical system called axis of symmetry. Now, left hand side space is always considered as object and the right hand side space is considered as a image space. There is one plane in object space, corresponding to it there is another plane in the image space. Then what is the importance about this point? આને બરાબર સમજીએ કે આ બે પ્લેન કેવા છે, શા માટે આપણે અહીંયા મૂક્યા છે. So when we place object anywhere in object space, ગમે ત્યાં આપણે મૂકીએ object space માં, કોને મૂકવાનો છે? Object. Then from this object there is lots of waves started and they pass this plane and they incident on the optical system. And suppose we consider one point only. અહીંયાથી એક point, એક જ ray આપણે consider કરીએ છીએ. And that ray started from the object and it crossed the plane at this height. And it incident on the optical system. Then the same ray, when it emerged from this plane, which is in image space, then it emerged at the same height. Then we can say that when the ray passing through the both plane, they cross the plane at the same height, and therefore the magnification corresponding to these two plane is unity, and therefore this plane they are called the unit plane because their magnification with respect to them is unity. So this is very important concept. There is one plane in object space, corresponding to there is one plane in the image space. Related to them, the magnification m is unity, then they are called the unit planes. So any paraxial ray started from this plane, unit plane, in the object space will emerge from the unit plane in the image space at the same height. This is the significance of the unit plane. And let us assume that the distance of unit plane of object space is du1 for the optical system, and distance of unit plane of image space from the optical system is du2. So du1 and du2 are the position of two unit plane. One is in object space and other is in the image space. We know the magnification equation. Magnification equation is equal to C minus AD2 is equal to 1 upon B plus AD1. And if we consider this object space, for example, suppose our object is here itself here, then image will appear on the another plane and corresponding to them magnification is unity. એટલે કે જેટલી હાઇટનો ઓબ્જેક્ટ અહીંયા મૂકીએ એટલી જ હાઇટની ઇમેજ આપણને મળે યુનિટ પ્લેન પર, બીજા યુનિટ પ્લેન પર. તો if we have this case, then d1 is equal to du1. તો જ્યારે ઓબ્જેક્ટ ડિસ્ટન્સ કેટલું હોય? du1. અને જ્યારે ઓબ્જેક્ટ ડિસ્ટન્સ du1 હોય ત્યારે મેગ્નિફિકેશન કેટલું હોય? મેગ્નિફિકેશન કેટલું હોય? 1 હોય. બરાબર, આપણે હમણાં ડિફાઇન કર્યું કે યુનિટ પ્લેન એવા જ પ્લેન છે કે જેમના માટે મેગ્નિફિકેશન હંમેશા 1 હોય. તો we can say that m equal to 1 and m equal to 1, then it is equal to 1 upon b plus ad1 is equal to 1. We can simplify this equation, and if we simplify this equation we can easily get the value of du1, that is the position of unit plane in object space. So if we simplify this, b plus adu1 is coming on the left hand side, so b plus adu1 is equal to 1, and now you can find out the value of du1. What should it be its value? Simplify the equation and find the value of du1.
1 minus b by
du1 is equal to 1 minus b upon a. That is the position of the unit plane in the object space. Similarly, the same idea we are using to find the position of the unit plane in the image place. So for image space plane, we have d2 is equal to du2. We get image on the second plane, or our height of them must be equal, that is equal to m equal to 1, and therefore m equal to 1 is equal to c minus d2, but now d2 is replaced by du2. And now we can also find out the value of du2 using this equation. What is its value? du2 equal to
C minus 1 by
C minus 1 by.
very good. And using this simplified this equations, we get du2, the position of the unit plane, is equal to c minus 1 upon a. We call this as equation 1 and equation 2. These are the position of unit plane for any complex optical system, where A and D, they are the system matrix element. This is C and A, also they are system matrix element. Now, see, we place object here. If we place object here, the distance of object from the unit plane is suppose u. And we know that all the left hand side distances are considered as negative. So we consider them as negative. So let us consider the distance of the object from the unit plane is u. And we get the image on the other side, and that is equal to v. The total distance, the distance of the object from optical system is considered as capital D1, and distance from the image from the optical system is considered as capital D2. Then we can say that here this D1 is nothing but the summation of this u and du1. So from this geometry of the figure, minus d1 is the summation of minus u minus du1. And similarly, we can have that d2 is equal to v plus du2. This equation is multiplied by minus 1, and we get the equation d1 equal to u plus du1. Substituting equation 1 and 2, that is the position of the unit planes, we already know. And if we substitute them in these equations, we get the equation d1 is equal to, our object distance is now represented as d1 equal to u plus 1 minus b upon a. We call this as equation 3. And similarly, in du2, this equation du2 is substituted from equation 2. We get the equation d2 is equal to v plus c minus 1 upon a. That is our equation number 4. Wherever there is object distance, wherever there is image distance, that is when we have optical system, object and image, we have to consider one spatial relation. And what that relation is? If we have object there, if we have image there, and if we have system matrix there, that is our optical system there, then we have to consider the relation, and that relation is called a d1 d2 plus b d2 minus c d1 minus d is equal to 0. So we use this relation. This last two terms, they are negative, so they are coming on right hand side. And d2 is in the both of this first and second term. So d2 is considered as common and taken outside. So that is a d1 plus b into d2 is equal to c d1 plus d. We already know the value of d1 and value of d2. So using equation 3, only we are going to first substituting equation 3 in this equation. We are not going to first this d2 is not substituted here. only we first substitute this d1 here. So when we substitute d1 in this equation, so wherever there is d1, we have to substitute u plus 1 minus b upon a plus b, d2 remain as it is equal to c into d1. So c into d1, that is u plus 1 minus b upon a and plus d. This is considered as least common factor. So if we simplify this bracket, this and this bracket, then u is multiplied by a and then divided by a. So simplifying the bracket, we have a into au plus 1 minus b divided by a plus b remain as it is, and then d2 is equal to c. Again this is au plus 1 minus b upon a and then plus d. This a is this is cancelled out, it is in numerator and this is in the denominator, so a is cancelled out. Here we simplify this again. So a is multiplied with d. So now we can say that this is a is cancelled out. So on left hand side, if a is cancelled out, our left hand side term is like this: au plus 1 minus b plus b and into d2 is equal to c is multiplied with this bracket au plus 1 minus b, and this a is multiplied with d. So that is equal to plus ad and divide by a. Okay. Now on left hand side, this is negative b, this is positive b, so it will cancel out. So minus b plus b cancelled out, and therefore we have au plus 1 into d, અને આપણે છૂટો પાડી દઈએ bracket, તો acu plus c minus bc plus ad and divide by a. Now we know that here determinant s is equal to bc minus ad and bc minus ad is equal to 1. So here in the right hand side, the last two terms, they are minus bc plus ad. So we are going to substitute here minus bc plus ad. What should be its value? We are going to substitute here instead of minus bc plus ad.
Minus 1.
Minus 1.
Minus 1.
So
Minus 1.
wherever there is minus bc, right? Minus bc plus ad, we have to substitute here minus 1. And then this is coming on right hand side, so it is in the denominator. So d2 is equal to acu plus c, and then there is a minus 1. So minus bc plus ad is now replaced by minus 1, and then here there is au plus 1 is in the denominator, right? Now we already know the value of d2. From equation 4, we substitute the value of d2 here. So when we substitute d2 in this equation, d2 equal to v plus c minus 1 upon a is equal to acu plus c minus 1 divided by a in the bracket au plus 1. The c minus 1 upon a is coming on the right hand side, so it will become negative, and therefore our equation now is equal to v is equal to first bracket and then minus c minus 1 upon a. So here you can simplify this equation. Here a is already there, so we can only multiply au plus 1 with the second term. So the next is we are going to simplify this equation, and to simplify this equation, au plus 1 is multiplied with c minus 1. કરો મલ્ટિપ્લિકેશન અને આન્સર કેટલો આવે છે જુઓ તો. સિમ્પ્લિફાય કરી દો આખું ઇક્વેશન. હું થોડો ટાઈમ આપું છું. આવ્યો આન્સર? કરો છો કે નહીં? ખાલી શું કરવાનું છે? AU પ્લસ 1 ને C માઇનસ 1 વડે મલ્ટીપ્લાય કરીએ તો નેક્સ્ટ ટર્મ ઇઝ લાઈક ધીસ: ACU પ્લસ C માઇનસ 1 માઇનસ C minus 1 into AU plus 1 and divide by A upon AU plus 1. આવ્યું આવું?
Yes, yes, ma'am.
હવે આ ટર્મને એક્સપાન્ડ કરવાનું છે. આ ટર્મને એક્સપાન્ડ કરી અને સિમ્પ્લિફાય કરો. Next term is this: ACU plus C minus 1 minus in the bracket ACU plus C minus AU minus 1, and in the denominator there is A upon AU plus 1. Now we are going to consider multiplying this term with negative sign. So if we multiply all of this term with negative sign, then ACU plus C minus 1, then minus ACU, then this is minus C, then this plus AU, and then this is plus 1. Here ACU plus and this is negative ACU, so it will cancel out. Similarly, plus C and minus C cancel out. Similarly, minus 1 and plus 1 cancel out. So we left with this equation: V equal to AU upon A bracket ma AU plus 1. A and A is also cancelled out. So the last equation is like this: V upon U, V equal to U upon AU plus 1. This AU plus 1 is coming on the left side, so it will be multiplied by V. So next equation is V into AU plus 1 is equal to U, or AVU plus V is equal to U. So we can say that AVU plus V is equal to U, and the equation is divided by VU. So if we divide each and every term of this equation by VU, then our next equation is like this: we divide first term by VU, second term by VU, and third term also by VU. So here VU and VU, first term VU and VU is cancelled out. From the second term V is cancelled out, and from right hand side term U is cancelled out. So we get this type of equation: A plus 1 upon U equal to 1 upon V. Now 1 upon V minus 1 upon U equal to A. And we know that element A gives us, what is the significance of element A? A equal to
1 upon F.
Very good. So A equal to 1 upon F. So this equation can look like this: 1 upon V minus 1 upon U equal to 1 upon F. V is the image distance, but image distance from the unit plane. U is the object distance, but object distance from the unit plane. And this equation exactly look like this: 1 upon D2 minus 1 upon D1 equal to 1 upon F. This is called length equation. આવું તમે જોયું છે ને equation?
Yes, ma'am.
હા, તો આ જ equation છે. આવું જ equation આપણે unit plane થી, if we consider all the distances from the unit plane, we can get same type of equation. And particularly if there is a complex system, then we have to first identify the position of the unit plane, કારણ કે આ equation thin length માટે જ છે અને એક જ લેન્સ માટે છે. જ્યારે આ ઇક્વેશન પૂરી ઓપ્ટિકલ સિસ્ટમ માટે સેટિસ્ફાય થાય છે. તો અવર પોઝિશન ઓફ યુનિટ પ્લેન they are very important, and from that position we can calculate the distances of object and image, and then we can use that formula. So if distances are measured from unit plane, the focal length of the system can be calculated, and the length equation can be satisfied when the distances are measured from the unit plane for any complex optical system. હવે આપણી પાસે એક થીક લેન્સના સિસ્ટમ મેટ્રિક્સ એલિમેન્ટ આપણી પાસે છે. આ લાસ્ટ લેક્ચરમાં આપણે ડિરાઈવ કર્યા હતા. A ઇક્વલ ટુ શું છે? તો P1 પ્લસ P2 માઇનસ P2 P1 T અપોન N2. B ઇક્વલ ટુ 1 માઇનસ P2 T અપોન N2. C ઇક્વલ ટુ 1 માઇનસ P1 T અપોન N2 and D ઇક્વલ ટુ માઇનસ T અપોન N2. તો આપણી પાસે ABCD થીક લેન્સના છે. તો આ થીક લેન્સના ABCDનો યુઝ કરી અને આપણે શું શોધવાનું છે? યુનિટ પ્લેનની પોઝિશન. કોના માટે? થીક લેન્સ માટે. થીક લેન્સ માટે યુનિટ પ્લેનની પોઝિશન શોધવા માટે we are using the equation du1 equal to 1 minus b upon a and du2 equal to c minus 1 upon a, where b is here, c is here. So we can easily substitute b and a from these equations. તો આપણે b અને a ની વેલ્યુ અહીંયા સબસ્ટિટ્યુટ કરી દઈએ તો we get this equation. Wherever there is b, આ રહ્યું, એને આપણે અહીંયા સબસ્ટિટ્યુટ કર્યું 1 minus b and in the denominator there is a. તો આ છે du1. Similarly we get the equation of du2. એના માટે c હોવું જોઈએ તો પહેલા c આવ્યું, આ રહ્યું c minus 1 and divide by a. So this is our a. Okay. આ બંને ઇક્વેશનમાં આ 1 છે, આ +1 અને આ -1, તો 1 અને -1 કેન્સલ આઉટ. એવી જ રીતે અહીંયા પણ આ +1 છે અને આ -1 છે, તો +1 અને -1 કેન્સલ આઉટ. So the position of unit plane for thick lens system is represented by this equation, where P1 and P2 they are power of the refraction. હવે કોઈ પણ થીક લેન્સ છે અને આપણે કન્સિડર કરીએ છીએ કયો લેન્સ? તો કન્વેક્સ લેન્સ. એ કેવો કન્વેક્સ લેન્સ છે? ડબલ કન્વેક્સ લેન્સ. ડબલ કન્વેક્સ લેન્સ એટલે કે એમની R1 અને R2 બંને કેવા હોય? સેમ. તો આના માટે પાવર P1 ઇક્વલ ટુ N2 માઇનસ 1 અપોન R1. આ ઇક્વેશન છે આપણું P1 નું પાવર પહેલા રિફ્રેક્શન માટેનો N2 માઇનસ 1 અપોન R1. બીજા રિફ્રેક્શનનો પાવર હોય 1 માઇનસ N2 અપોન R2. પણ જો અહીંયા આપણે શું કન્સિડર કર્યું છે? માઇનસ R2. તો હવે આપણે આ સમજવાનું છે કે શા માટે. આપણી પાસે બે પ્રકારની સરફેસ છે. સપોઝ ધીસ ઇઝ વન સરફેસ એન્ડ લાઇટ ઇન્સિડન્ટ લાઇક ધીસ. તો કર્વ ઓફ ધીસ સરફેસ ઇઝ ઓન ધ સાઇડ. જે બાજુ આ જે રે ઇન્સિડન્ટ થાય છે એ જ સાઇડ ઉપર કર્વ છે. Then in that case, R is considered as positive. Radius of curvature positive consider કરવાની. અને બીજું જે છે સરફેસ એમાં આ રે આ પ્રમાણે ઇન્સિડન્ટ થાય છે અને એનો કર્વ કઈ બાજુ છે? એની ઓપોઝિટ સાઇડ પર. તો ઇફ ધ કર્વ ઇઝ ઇન ઓપોઝિટ સાઇડ, આ જે સાઇડ પર ઇન્સિડન્ટ થાય છે એ જ સાઇડ ઉપર એનો કર્વ છે, આ એની ઓપોઝિટ સાઇડ પર છે. એન્ડ ફોર સચ એ સરફેસ R is as negative. તો કોઈ પણ કન્વેક્સ લેન્સને કન્સિડર કરીએ આ પ્રમાણે કન્વેક્સ લેન્સ, તો એના માટે ફર્સ્ટ R is considered as a positive અને સેકન્ડ R is considered as શું કન્સિડર કરવાનો એને?
નેગેટિવ.
આટલું બરાબર ધ્યાનમાં રાખવાનું. ધારો કે કન્કેવ લેન્સ છે, તમને ખબર છે કન્કેવ લેન્સ કેવો હોય. તો કન્કેવ લેન્સની પહેલી સાઈડ પર રે ઇન્સિડન્ટ થાય તો પહેલી R1 કેવો હોય?
માઇનસ.
કારણ કે કન્કેવ લેન્સ કેવો હોય આપણો? આવો હોય. બરાબર. કન્કેવ લેન્સની પહેલી સરફેસ આવી હોય અને બીજી સરફેસ આવી, તો પહેલા માટે R1 કેવો હોય? નેગેટિવ. અને બીજા માટે R2 કેવો હોય?
પોઝિટિવ.
બરાબર. તો અહીંયા આપણે P1 અને P2 માં આ કન્સિડર કરીએ છીએ. તો P1 ઇક્વલ ટુ P2 બાય કન્વેક્સ લેન્સ માટે P1 ઇક્વલ ટુ P2 બંને માટે P1 અને P2 કેવા થઈ ગયા? સરખા. તો હવે N2 માઇનસ 1 અપોન R, N2 માઇનસ 1 અપોન R. તો અહીંયા du1 ઇક્વલ ટુ P2 એન્ડ P2 ઇક્વલ ટુ N2 માઇનસ 1 અપોન R ઇન્ટુ T અપોન N2. એ જ રીતે P1, તો P1 ઇક્વલ ટુ ટ્વાઇસ, P1 અને P2 સરખા છે એટલે કે ટ્વાઇસ N2 માઇનસ 1 અપોન R અને માઇનસ P2 ઇન્ટુ P1 બંને સરખા છે એટલે N2 માઇનસ 1 હોલ સ્ક્વેર એન્ડ ઇન્ટુ T N2. And similarly, we get the position of du2. Here we can have du2. So this is du2 and 2 is equal to n2 minus 1. Here this is negative sign. So there is negative sign and n2 minus 1 upon r and then t upon n2. And in the bracket, this, तो आनु छे, sorry. आनु simplification छे, du1 is equal to n2 minus 1 upon r, t upon n2. Here there is two term, so n2 minus 1 upon r is common. In the bracket there is twice minus n2 minus 1 upon r into t upon n2. In the denominator and numerator there is n2 minus 1 upon r, so it will cancel out. So ultimately we get du1 is equal to t upon n2 in the bracket twice minus n2 minus 1 upon r into t upon n2. And similarly, if we carry out all this calculation again, we get the position of the du2 and du2 equal to minus t upon n2 in the denominator twice minus n2 minus 1 upon r and then multiply by t upon n2. તો આ છે position. હવે generally thickness is always less than and less than r. તો આપણે અહીંયા last term માં અહીંયા જોઈએ તો t is very very small compared to r. So we can say that last term can be neglected. So in the both of this denominator, the last term is neglected, then the position du1 is equal to t upon twice n2, position du2 is equal to minus t upon twice n2. So these are the position of the unit planes for the thick lens system. Thick lens no jo thickness खबर होय, जो एनो refractive index खबर होय, तो we can find the position of the thick lens or position of the unit plane for the thick lens. For any general lens, આપણે હવે બાયકન્વેક્સ લેન્સ છે પણ એમાં R1 બાયકન્વેક્સ લેન્સ નથી પણ કન્વેક્સ લેન્સ છે સિમ્પલ, તો T1 equal to n2 minus 1 upon R1 અને P2 equal to 1 minus n2 upon minus R2. Then we have 1 upon f equal to P1. P1 equal to n2 minus 1 upon R1. P2 equal to 1 n2 minus 1 upon R2 negative. And then P2 and P1 n2 minus 1 whole square T upon n2 R1 R2. So substituting all this value P1 P2 in this equation and n2 minus 1 is common from first and second term, we get this type of equation. 1 upon f equal to a equal to n2 minus 1 in the bracket 1 upon r1 minus 1 upon r2 and plus n2 minus 1 square then t upon n2 r1 r2. So this is the focal length of the thick lens system. So this is about the unit plane. હવે આપણે next consider કરવાના છે second plane, and second plane they are known as the nodal plane. પેલા જેટલી અગત્યતા નથી આની, અને એ જે nodal plane છે they are generally in exam point of view it can be asked as a definition what is nodal plane. So you have to understand it like this. I can explain you it for optical system. Acha apni optical system. As usual, there is object space and image space. There is one plane in the object space, corresponding to it there is another plane in the image space. Unit plane ની અંદર શું હતું કે એમનું linear magnification corresponding to these two, they are unity. અહીંયા આગળ શું છે કે when the ray passing through this plane and incident on the optical system will emerge from the second image plane, that is second nodal plane, at the same angle. So there is one plane in the object space, corresponding to it there is another plane in the image space, and related to them angular magnification is unity, then they referred as the nodal plane. એને આપણે સમજીએ રે ડાયાગ્રામ થી, તો આપણે એક રે કન્સિડર કરીએ, રે ઇન્સિડેન્ટ on the optical system, and it makes angle alpha at point this, nodal plane પર આ point છે, it makes alpha angle. And suppose the same ray emerge from the optical system, and when it come out from this image space nodal plane, then it has same angle alpha. તો આ બીજા plane પર એનો angle કેટલો હોવો જોઈએ? alpha. Then we can say that corresponding to this two plane there is the angular magnification is unity. બંનેના angle સરખા હોય તો angular magnification is unity. So we can say that they are any paraxial ray starting from the nodal plane in object space at angle alpha that will emerge from the nodal plane in the image space at the same angle alpha, then we can say that they are called the nodal plane. Let us assume that the distance of nodal plane, they are considered as dn1 in object space, that is the distance of nodal plane from the object space from optical system, and similarly dn2 is the distance of the nodal plane of image space from the optical system. So now we want to find out the value of dn1 and dn2. પહેલા du1 અને du2 આપણે લઈ આવ્યા છે. કોઈને યાદ છે કેટલું છે du1? du1 કેટલું આવ્યું?
P2 T upon 1 minus B upon A.
1 minus A by B.
1 minus b upon a અને c minus 1 upon a, આ છે એના position, બરાબર. Now similarly we are going to find the value of dn1 and dn2, અને એના માટે આપણે કયા equation use કરવાના છે? તો let us consider we are concentrate on this point n1 અને n2. આ n1 અને n2 બે પોઈન્ટે આપણી પાસે એંગલ કેટલો છે? આલ્ફા છે. તો the incident ray at point n1 make alpha angle with z axis, and by the definition of nodal plane the emerging ray also make the same angle at the nodal point n2 with z axis. Both the ray they are propagating in the medium of refractive index n. તો બંને બાજુ સેમ મીડિયમ છે અને બંનેનો રિફ્રેક્ટિવ ઇન્ડેક્સ છે n જેટલો. So at point n1 we can say that optical directional cosine lambda 1 is equal to કેટલા થાય? n into alpha. We call this as equation number 1. આને આપણે કહીએ છીએ nodal point n1 is represented by lambda 1 and its value is equal to n into alpha. Similarly at point n2 point બંને કેવા પોઈન્ટ છે? એક્સિયલ પોઈન્ટ, x ઉપર જ આવેલા છે અને z એક્સિસ સાથે કેટલો એંગલ બનાવે છે? આલ્ફા એંગલ. તો n2 the optical directional cosine lambda 2 equal to n into alpha. Naturally lambda 1 અને lambda 2 કેવા છે? equal છે. So we can say that angle are same, refractive index are same, and therefore the optical directional cosine at n1 and n2 nodal points n1 and n2 are always same. Now in earlier topic we have considered or we come across this equation lambda 2 equal to b plus ad1 into lambda 1 minus ax1. આવું આપણે એક equation જોયું. આ બંને point છે n1 અને n2, both point they are axial point, અને axial point માટે x1 ની વેલ્યુ હંમેશા કેટલી થાય? 0. કારણ કે ધારો કે અહીંયા કોઈ પોઈન્ટ આવ્યું હોય તો આપણે એક્સિસ ઓફ સિમેટ્રી થી ડિસ્ટન્સ લઈએ, અધરવાઇઝ આ આ પ્લેન માટે આ પોઈન્ટ માટે નોડલ પોઈન્ટ માટે x1 ની વેલ્યુ કેટલી થઈ જાય 0. So for both the
0.
nodal point the axial point and therefore we can say that lambda 2 equal to b plus ad1 into lambda. આ ઇક્વેશન છે આપણી પાસે. હવે આપણી પાસે બીજું પણ ઇક્વેશન છે અથવા આપણે એને lambda 2 by upon lambda 1 કરીએ તો b plus ad1. Also we have c minus ad2 into b plus ad1 is equal to 1. આ ઇક્વેશન આપણે લાસ્ટ લેક્ચરમાં લઈ આવ્યા હતા. તો using this equation b plus ad1 can also be represented as c minus 1 upon c minus ad2. So lambda 2 upon lambda 1 is equal to b plus ad1 is equal to 1 upon c minus ad2. So with this equation now we are going to find out the position of the nodal plane. First we are concentrating upon the object space plane. Suppose we have d1 equal to dn1. તો જ્યારે આપણી object space છે એ nodal plane છે એ object space object distance છે એ dn1 જેટલું હોય, then we can say that n alpha, that is our lambda 2 upon lambda 1, n1 અને n2 point છે આપણા પાસે corresponding point. So n alpha upon n alpha equal to b plus adn1 is equal to 1. So when we have nodal point 1, then in object space it satisfies the equation, and that equation is equal to b plus ad1, and b plus ad1 is now replaced by b plus a dn1 is equal to 1. And therefore m alpha is equal to 1 is equal to b plus a dn1. And from this we can say that dn1 can be calculated, and dn1 is equal to 1 minus b upon a, and we call this as equation number 4. Similarly for image space માટે d2 બરાબર કેટલું લેવું પડે આપણે?
dn2.
dn2 nodal point 2. So d2 equal to dn2, and at dn2 we can say that n alpha upon l alpha, magnification is equal to unity, angular magnification is equal to unity. તો આ ઇક્વેશનમાં c minus ad2 d2 બરાબર dn2 and that is equal to 1, and therefore we can say that m alpha is equal to 1 is equal to c minus a dn2, and therefore dn2 is equal to c minus 1 upon a. And this is our equation number 5. So this equation 4 and equation 5, they are the position of the nodal plane for any complex optical system. They only depend on the system matrix element. કયા system matrix element છે? A, B, C અને D તો છે જ નહીં. તો A, B, C ખબર હોય આપણે system matrix element, તો આપણે easily unit plane અથવા nodal plane ને calculate કરી શકીએ. હવે આપણે તમે કમ્પેર કરો પોઝિશન ઓફ યુનિટ પ્લેન અને પોઝિશન ઓફ નોડલ પ્લેન, બંને કેવા છે જુઓ.
સેમ
હે ને? તો જ્યારે ઓપ્ટિકલ સિસ્ટમ એવી હોય કે જેમાં ઓબ્જેક્ટ સ્પેસ અને ઇમેજ સ્પેસ બંનેના રિફ્રેક્ટિવ ઇન્ડેક્સ કેવા હોય? સરખા. એર મીડિયમમાં મૂકીએ તો આપણે ઓબ્જેક્ટ સ્પેસ અને ઇમેજ સ્પેસના બંનેના રિફ્રેક્ટિવ ઇન્ડેક્સ સેમ હોય, then we can say that unit plane always superimpose on the nodal plane. So this is how we can say that we can find the position